Welcome to the Maintainable Software Podcast, where we explore the art of improving existing software with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we are joined from sunny, or maybe foggy, London, Alex Omeyer, who is co-founder and CEO of Stepsize. Alex Omeyer, we're so glad to have you join us today on Maintainable. Welcome.
Thanks for having me, Robby.
So as you reflect on your experience in the industry, what do you believe are a few characteristics of, dare I say, maintainable software?
There's one that comes to mind straight away that actually has some research backing it up, and it's this concept of ownership. I think that we can talk about specific parts of any code base. If a code base is going to be high quality, very maintainable, it's probably because there are high levels of ownership of that code. And I say it's backed by some research. You can look it up. Microsoft did a great job. And they figured out that if a piece of code was shipped consistently and sort of consistently modified by a given person or a given team, as opposed to having lots and lots of people touching it, it ends up being less prone to bugs. So I won't bore you with the details, but it's a really fascinating idea that I think sort of will influence how people set up the different teams in their engineering organization and what they're responsible for and what they expect from them.
That's interesting. I definitely have to have you send over a link to that research. I'll include that in the show notes. I'm curious about that. Do you think that there's a high quality, limited number of bugs? Does that work well? If the research touches on when teams change, people come and go, and does that deteriorate? Because I think there's also the concern that a lot of people talk about is just like these kind of silos, whether it's at a team or on someone specific knows this part of the software really well, and so things are taken care of. But as soon as they're gone, what then happens?
Yeah, I know where you're headed with this. It's I guess ownership is a spectrum, right? And the research isn't saying that one and only one person should be responsible for any given part of your code base, right? What it's saying is it should probably be a team. Let's say you have a team in charge of the third-party integrations code, and that if you start ending up in a situation where engineers who aren't part of the third-party integrations code have to modify this code base for reasons, whatever there might be, you end up in situations where they're more likely to introduce bugs. And so I say ownership is a spectrum. It probably starts with the situation you're describing where your bus factor is really terrible, where only one person knows how to modify this code. And if they leave the organization or rotate to a new team, you're in trouble. And it goes all the way to some crazy situation where every engineer in the 100-person team has modified this thing. And usually when that happens, it grows into some kind of monster, a gigantic class that has loads of hairs all over it. And there's something in the middle, right, which is clear ownership of the code by a given team is how I like to think about it as opposed to an individual. Because if a team owns the code, it's rarely the case that everyone takes off at the same time. Otherwise, you've got some other problems to deal with. And that means that any new member who joins that team is going to be able to learn from these people as to what's up with the code, how to modify it, what quirks it has, etc., etc.
Do you have a strong opinion on how, say, those quirks are captured within a team?
That's what we're all about, right? I mean, I'll tell you what I'm up to day to day so that you have the context. I'm building a company that's building a SaaS product to help people deal with technical debt. And everything that I'm relaying here is nothing that I've invented. I spend as much time as I can speaking to the best engineering teams that I can find, asking them, how do you deal with technical debt? What worked? What hasn't? And one thing that becomes clear, it sounds obvious, but it's actually a lot more challenging than it seems, is if you want to be able to manage technical debt and make good decisions about how to maintain your code base, where to invest your resources, you need to have visibility into your technical debt. And that's number one. It means that you need to have a list of your tech debt somewhere. You can start with creating a spreadsheet. You can track it in some backlog in your project management tool. Both have pros and cons. We've built a product to make this process 10 times easier than what it might be if you use these two alternatives. But it doesn't matter what you use, you need a list of your tech debt in your code base. And the next thing you need to be able to do is to somehow prioritize that list. And that's where things start getting a bit complicated. Imagine that sort of backlog of 100 or 1,000 issues in Jira. How do you decide how to allocate your engineering resources, your sort of 10 to 30% of your sprint, to a few of these things when there are so many? We recommend that people prioritize the debt that has a clear business case behind it. I'll give you an example. If an engineer, and actually that's a different problem that maybe we'll talk about a bit later, if an engineer comes to a PM or some non-technical person and tells them, look, we should really be using joins in our SQL queries, that won't speak to them. That isn't much of a business case. It's a good thing to do, probably, but will it move the business forward? I don't know, right? Whereas if the engineer says, well, look, we should be using joins because our SQL queries will then run sub 1 second instead of in 30 seconds, and that means that the customer that left us last week because they were sat in front of their dashboard for 5 minutes while it was loading wouldn't have gone, then it means that the business case is reducing churn, right? And that's a lot easier to sell, it's a lot easier to communicate. And these are things that you need to do because, well, the resources that you allocate to maintaining your code base are the same resources that you'd allocate to shipping new features. And what you're competing against is, when you ship a new feature, typically it's relatively easy to draw a straight line from we build this good stuff happens to the company. We ship this, engagement goes up. We ship this, we close deals. And it's really hard to do this for technical work that relates to maintenance and relates to technical debt. And B, it's a thing that engineers aren't very good at doing generally. The more experienced ones tend to get better at it. It just seems to intuitively, that's how they realize that things go. And so the second element, if you want to manage technical debt properly, after having a list of that debt somewhere, is deciding what extra metadata you're going to track with that list so that you can then prioritize it. If you don't deal with technical debt, 3 things might happen. 1, you're probably going to waste a lot of time because it'll be very hard to ship things at pace. 2, you're probably going to have a lot of bugs and support tickets and things like that. The quality of your software will be impacted. And 3, your engineers are probably going to be unhappy and they might even end up leaving the company. These are the sort of 3 main consequences of technical debt that come to mind. And so if you're able to tell for any piece of debt how much it puts any of these 3 at risk, you can then prioritize accordingly. This part of the code base, we consistently lose a lot of time, and this tech debt that we have here is consistently the root cause for these bugs that keep coming up and these support tickets that we have to deal with every week. And this part of the code over there, because of these pieces of debt, is making every engineer that ever has to touch it very miserable, right? If you have these 3 pieces of information or some proxy, you're going to be able to decide which you prioritize first and allocate your resources properly. That's what our product is all about, but like I said, you can get started in simple ways as well.
I think you make some really good points there. I'm curious about, you touched on how engineers aren't always really good at conveying the business value. I mean, every organization is a little bit different, and a lot of things that are in the product backlog are usually driven by the product team, and they know they need to justify the business value to get like a new feature added or to change things. But then it's kind of like from the other side, it can be this challenge of like, well, someone else figured out the business value. It's like, so it's just like, here's the pain points that we're dealing with as an engineering team. What is your take on the metaphor technical debt, not knowing that you have a product that focuses on that? And it can be a little contentious of what is or isn't technical debt. What do you believe developers often get wrong when they're discussing technical debt? Are they mislabeling it?
Yes. Yeah, I love the question. If you look up content about technical debt online, you're probably going to find a lot of people geeking out about the different types of technical debt. I'll say design debt, code debt, process debt, architecture debt, this debt, that debt. I think that's fine if it helps you identify debt and recognize it when you're looking at it, right? The way I define technical debt for myself, and I guess our working definition at Stepsize, is as soon as you've decided that a piece of code is a liability for whatever reason, you can call it tech debt, and you can add it to that list of debt that you're tracking, right? Simple. As far as the metaphor goes, I think it's one of the best metaphors ever. I mean, when you think about it, technical debt is it's not a bad thing. You can use it for extra leverage. You can take out a loan to ship faster because you want to get your thing in front of customers and learn from it. The only sort of way in which it can become bad, and it's the same for financial debt, is if you're reckless with it, right? You sort of take on a loan without even knowing that you have, without even knowing the principal that you have to pay back, without even knowing the terms of the deal, the interest that you're going to have to pay back. And that's the trouble with technical debt, is it's not like you get a bit of fine print to work through to understand the terms of the deal, right? You sort of have to somehow figure them out while you're working in this code base with your team. And so I think the metaphor is fantastic and really helps non-technical people understand what it is that we're talking about. I think that sometimes people get lost in the details and sort of overthink it a little bit. So I would just work with this simple definition of, look, if you've decided it's a liability, then it's debt and you're going to have to do something about it. And generally speaking, I think another thing that people forget about technical debt is that it's just inevitable. It's not due to incompetence. In fact, you can imagine an engineer shipping the perfect solution to the problem you're fixing today, right, with your software, and fast forward 6 months, your assumptions about the problem that you were fixing are actually wrong and your system is inappropriate, or things have evolved. You know, you thought that you were going to be selling your software to companies in the UK, and all of a sudden it grew super fast and you have to support 15 different currencies and payments, and you just weren't ready for that. And why would you be, right? You shouldn't future-proof to that extent. You know, I think that if people understood these few things, there would be a lot less, it would be a lot less hard to talk about tech debt because there wouldn't be so much of a blame game. It would be just a sort of fact of life that we build software. There is a cost to be paid to maintain this thing, and if we don't pay it, things will go wrong. And there are ways to bridge this gap between, heavy air quotes on this one, the business side and the engineering side. But I'm just talking about, what we were saying earlier about making the business case for any given piece of debt.
It's interesting how, and even just as we're talking through this a little bit, how we start to separate the idea of business from the engineering as like two separate things, but the engineers are part of the business. They're there to provide value and help influence. And so it's not like there's this need to necessarily be this them and us type of relationship that seems to sometimes materialize. Like they're subjecting me to, as the product team is subjecting us to these unbearable deadlines and goals that they have. And like we're having to deal with all the mess of all this stuff, all the sacrifices we're having, the corners we've cut, and it's their fault for not, and it becomes this weird thing. And talk about a bunch of different people as well on on the podcast and outside of this, where you talk about maybe there's teams that are able to figure out like, okay, we're going to use 10 to 30% of our sprint to focus on dealing with some technical debt of some sort, or improving things, or however you want to label that, right? And based on your research and talking with different some of your customers, have you found some good baby steps that they can start to like actually start dealing with it, rather than just being, well, it's on a backlog somewhere, but nobody from the product team is dragging that up to the next sprint? And so I'm guessing they don't think that's important, they being the product team, separate somehow.
Yeah, you gave me so many thoughts with this comment. I'll comment on the first bit about how we often talk about engineering and the rest of the business is separate. I guess that's the problem, right? That's the point. It's not separate. We're all working together to achieve some business goal that we decided was worthy, and the software that we're building is in service of that business goal, and everything that we're doing should be in service of that goal. It just tends to feel like an us and them situation where people fail to communicate with each other. And I often speak to companies who have very good engineering cultures and just generally company cultures. I call them sort of tech-led companies, where often one of the founders, maybe the CEO, is an ex-engineer. They understand technical debt, so they just give engineering the opportunity to make the decisions they want to make to manage the code base, right, as opposed to forcing their hand in any way. But at the same time, these people also understand that you can't just fix something because it's a pet peeve of yours. There needs to be some business value to it. And so they're on the same page and off they go, right? Now, as to how sort of a system you might use to deal with technical debt and little things that you can do. I told you earlier about the different types of tech debt and how people love to geek out about it. As far as sort of recognizing the process that you should use to deal with a given piece of debt, I think the only thing that matters is whether you're talking about a small, medium, or large piece of debt. And I'll define each quickly. The small piece of debt is a thing you can fix right then and there in the code base. You apply the Boy Scout rule. It is understood that it's part of engineers' jobs to do that, and they don't need anyone's approval. They don't need to create an issue. It doesn't need to go through sprint planning. They just refactor this function and rename these variables, and they get back to work, right? This is table stakes stuff that is driven by a healthy engineering culture that, in my opinion, every single company out there should have. And if they don't, it's probably one of the first things to fix, right? Now, small pieces of debt aren't the only thing you have to deal with. Sometimes you come across something that's a bigger job. And I call these the medium pieces of debt. These are the pieces of debt that can fit usually in that 10 to 30% of any sprint that is allocated to maintenance work. Sort of, you could call it a contract that some engineering teams have with product teams. Like, cool, we're going to have 30% of our capacity to deal with these things. Maybe they'll call it Refactor Friday or something like that, right? Now, where companies often fail on this front is that they forget that you need to track your tech debt to have visibility into it, and you need to prioritize it so that the work you do is in service of whatever business priority you decide to go after. And that effectively means having any piece of maintenance work go through the same channels as feature work would. You have to go through sprint planning and whatever process you're following, whatever version of the agile methodology, because that forces you to make the business case, to figure out the scope, to decide how you're going to do it, why you're going to do it, etc., etc. And these, you schedule them into your sprint, they go into the 10 to 30%, you address them, everyone's happy, off you go. Now, the final type of debt, the large pieces of debt, I define as anything bigger than that. You need to upgrade to some new version of Ruby. You've decided that your monolith is no longer the way to work. You need microservices. You're upgrading from Angular to React or whatever it is. And these jobs take more time. You can't fit them in the 10 to 30% of any sprint. The process is somewhat similar, though. You need to make the business case for why you need to upgrade from Angular to React. Maybe it will help you hire engineers. Maybe it will help you retain engineers because people want to work with the latest tech. Maybe it will enable new features that you couldn't build before. Maybe it will allow you to ship these things that you have on your roadmap faster. All of these things need to go into what you might call a technical proposal. And a lot of companies that I speak to, typically larger ones, will have some version of a technical steering committee. It's a big word, but it's super simple. Once a month, once a quarter, they get together with engineering and product leadership to evaluate these technical proposals. And these technical proposals typically emerge out of the sort of small and medium pieces of debt that the engineering teams are tracking. It comes bottom up, right? The people on the front lines have these problems. They get communicated with team leads, with engineering management. You might have your staff or principal engineers putting together proposals with the solutions they have in mind to these problems, and then these get discussed at this meeting. And it's the same deal. Which of these should we allocate resources to because they will bring the business forward and allow us to accomplish this objective that matters to us? Once they've made this decision, it goes onto their roadmap like any piece of feature work, and it gets executed on, right? So now it becomes part of product and engineering's job to do it. And so I think if you use this system, small, medium, large, it's not complicated, you'll have all your bases covered and you'll do great, I think, much better than the average software company out there.
We'll be back with our interview with Alex in just a moment. Hi, it's me, Robby. I wanted to take a quick moment to say thank you for making time to listen to the Maintainable Software Podcast. If you're finding these conversations valuable, please consider sharing a link amongst your peers on social media and or writing a review on Apple Podcasts to help spread the word. Do you know someone in the industry that I should be interviewing on Maintainable? shoot me an email to Robby with a Y at maintainable.fm and make your suggestion. And now, let's get back to our interview with Alex Omeyer. I really appreciate you walking through these different, say, sizes or of different types of technical debt. And do you think on those small ones, you mentioned like the Scout approach where you're trying to make things better than when you found them, right? And do you feel like that needs to be captured and documented in prior, or are you just saying that typically developers should just do that? They don't need to, you mentioned they don't need to ask for permission or prioritize it. They're there already. Where is that distinction where if it's something that they're annoyed with, but maybe it's kind of like not related to the projects that they're focused on right now, is that then considered kind of a more of a medium thing, or are they just going rogue and going and cleaning up things that annoy them?
Yeah, that's a good question. A few thoughts. I think when you start thinking about technical debt in these terms, making the business case for it, engineers want to build things that are useful and they also want to move the business forward. So I think it makes people aware. It helps them think about why am I doing this thing? Am I just mad because someone else wrote it in a way that's not how I would have done it? Okay, maybe I can leave it. Or is there a genuine reason to do this thing? We're talking about very small jobs like renaming variables, like refactoring some function that doesn't have you go down some crazy rabbit hole. I really think that it shouldn't even be discussed. It doesn't require any any tracking, any tooling, anything like that. You rely on whatever training your people have been through, whatever directions you've given them. So that's a sort of totally different topic where I'm really not much of an expert, but I think it relates to how you train your engineers. Like, you can think of it this way. If you come across a small piece of debt and you can't fix it for whatever reason, you should probably track it somewhere if you think it's worthy of attention at some point. And then it goes through the medium tracking channels, and maybe when it comes up at your retro or your grooming session or whenever you decide to spend 15, 30 minutes talking through these new issues that you've tracked, maybe someone goes, well, you know what, I can fix that in 5 minutes. I'll do it as part of this other feature that will have me touch this code. There's another method, by the way, that people use to justify dealing with a piece of debt is, okay, we're gonna ship this feature. Let's clear these pieces of debt that are in the code that we'll touch when we ship these features, because it'll help us do it faster, do it better, whatever it is.
Right. So for everybody in the audience listening, for those small things, just if anyone raises an eyebrow because you start making changes to variable names and such, just say that Alex said it was okay. That's normal. That's just what we're doing now. You don't have to ask for permission to do that. I want to take a quick step back. You touched a little bit on Stepsize, but could you tell us a little bit more about Stepsize and what prompted you to create it in the first place? What's your background and how did that kind of lead into this?
Yeah. Gosh, I'm wondering how far into the past I should go. I have 3 co-founders, and we're all different versions of data nerds. The 2 of them are data scientists, 3 of them are mathematicians. I used to work at SaaS companies that built their product on some data source and sort of extracted value out of it. And so we always had plans to build a business together. I mean, one of my co-founders is my brother. The other 2 went to sort of high school with us and then went to university, and we somehow got back together later on. And when we started looking at how people build software, we realized that there's an awful lot of data that's created as a byproduct of us building software. People just collaborating, whether it be Git data, issues and tickets from Jira, your pull requests in GitHub, all of this. And we started wondering about what kind of value you could extract out of that. So over the years, we started working on Stepsize back in 2015, and the company was incorporated in 2016. Over the years, we built different products that were all about helping engineers ship better software faster. They solve different problems. I'll give you an example. We had built a better Git blame extension for Atom that would allow you to see, the name of the real author who shipped most of this code, not just the last person to touch it, and grab all the context relevant to this code, as in the Jira ticket with the features that were shipped here, the pull request relating to this code, etc., etc. We got a few thousand people downloading it on Actim, and then we proceeded even further down this road because we realized, like, okay, why might you want to speak to the author of this code? Perhaps there's something that you don't understand about it, and we started looking at ways to automatically document code using this data. Why is documentation a problem? You could imagine a piece of code perfectly written, perfectly commented, being something that's still easy to digest for someone, even if they don't have the documentation. And we went down this rabbit hole and realized that the code that people are having a hard time understanding typically has a lot of technical debt in it. Why is technical debt a problem? Maybe it's because you can't measure it. Like, you can't really put a clear border around it. So we started looking into using code quality metrics and Git metrics to identify hotspots, hotbeds of technical debt in your code base. And, we'd show this to engineering leadership at the companies we were working with, and it'd be like, well, fascinating data, but what should I do now? Like, what next? Like, I've got these hotspots. How do I decide how I should allocate my resources? And that's when we realized that there's actually a problem that's slightly different that can be solved if you have the right contextual data that tells you about, I guess, which business objectives this code relates to and why you might want to start addressing it. And that's when we started working on this version of Stepsize. I think product was probably, we started working on it a year ago or something like this. And here what we're doing is we're starting from the premise that if you ask an engineer what's wrong with the code that they're working on, they'll be able to tell you. They'll say, this, that over there in the code that I spend all my time on is probably messed up and we should do something about it, right? But if you take a company with 10, 30, 50, 100 engineers, company leadership or the people who make the decisions about how to allocate engineering resources typically don't have this kind of visibility. Like, okay, everyone's got their opinion about what's messed up in the code base, but we don't have some aggregate, some macro view, some way to rank all these things and decide what to do about them. So that's the problem around visibility of tech debt that I was talking about earlier, right? You need to have visibility into your tech debt. And then we spoke to a lot of companies who were using, say, a Jira backlog where they'd have all of their tech debt issues, or some spreadsheet where they were tracking this stuff. And they consistently told us, look, I've got this massive list, but I don't know how to order it. So what ends up happening is all these things that we tracked in there go stale, and after 6 months we don't know what to do about it, so we haven't done anything, so people stop tracking that data. I no longer have visibility into my tech debt, and now I just have a massive backlog, and I'm sort of back to square one. I don't know what to do with it. And so we realized that if we built a product that allowed engineers to report tech debt when they come across it directly from their workflow, you would have an exhaustive list of the tech debt that's causing problems. And on top of, when you track this data with Stepsize, on top of saying this is the issue, you get to quantify the impact it's had on the business. This is how much time I lost because of this. These are the quality issues like bugs or outages or errors that we're getting because of this. And when your team's tracking data that way, you end up with very clear pieces of debt that should be at the top of your list to deal with because they're causing you the most problems. And then you go off and you address that. So that's roughly the journey. I've tried to summarize it as best I can, but there's so much.
I appreciate that. I hadn't got a chance to dig through the product yet, but I was curious when you say it's a place. So is that something that develop right now where the product's at? I'm sure as you're planning, you're probably likely continue evolving on it. But you mentioned you were speaking to some of the previous tooling that you'd been working on, kind of relying on the metadata and other things that are kind of happening within Git and your Jira tickets or whatever systems you're using. Is this something that developers are like, oh, I need to log into this other app right now and document it? Or is there something that there's ways that they can kind of communicate that information from within the work that they're doing somehow?
Yeah. So this is super important. It sounds like nothing, but just switching context from your editor to Jira or a spreadsheet to track some issue that you came across when you know that it's probably not going to get addressed, and you won't even, it'd be too much work to add the context that you need when you're tracking that in these tools. You just end up not really doing it. And that's why we went really heavy on the workflow integrations. I'll give you an example. I'll give you two examples. With Stepsize, you can, if you're in your editor, say VS Code, you can select any snippet of code, right-click, report tech debt, and send it. There's a little web view that opens, and you can type in any data you want to type in, send it, you're back to work. Or if you're reviewing some code in a GitHub PR, we have a little bot that allows you for any diff that you're looking at to say, look, it's not within scope to fix this right now, but we should keep an eye on it. Send it to Stepsize, right? And then that stuff all lives in a web app where you have, all the filters, all the dashboards and everything you might want to make sense of that data and prioritize that data. So yeah, we've had this feedback consistently. It's like before we had any kind of integrations, which by the way was before we built the product, because it's one of the first things we started with, was like, okay, but I need this to be ridiculously easy if I'm going to track this data. And we got there. So now we have a few hundred engineers who are reporting this data for their companies. We have a handful of customers who rely on the data that their engineers are tracking. And that was just step number one. If people aren't tracking data, then you can't make sense out of the data because you don't have any.
That's interesting. Yeah, I definitely have to take a look at that. I was reading through a couple of the articles on the Stepsize blog, and I was actually really was fascinated by some of the content in there. And so I appreciate you folks are doing a lot of research and sharing this information and distilling it down for us laymen's out here. And one of the posts that I came across talked about how there's like a stat that the average developer would say work approximately 41.1 hours a week, in a normal work week, and approximately 13 and a half hours were spent dealing with technical debt. So say 1/3 of that, give or take. So, which is kind of seen as a productivity loss. What is your take on that? Do you ultimately see time not spent on, say, producing new features or code as a net loss, or are we trying to get down to zero?
No, good question. Yeah. I guess I'll clear this one right off the bat. I don't think you can end up in a situation where you have zero technical debt. In fact, if you do, you're probably overdoing it and your competitors are going to beat you to market because, like we said, you can take on technical debt for good reasons and end up shipping your thing faster, earlier, and learning more, learning the things that you need to be able to design this system properly. Right, Martin Fowler has a good quote in one of his posts. By the way, his posts on technical debt are some of the greatest as well, where he says that his buddy of his who told him that it sometimes takes up to a year of working on a piece of software on a problem to figure out the best design for it, right? So no one's going to get it right off the bat. No one's going to get to zero technical debt, and that is not the goal. If we go back to the way we were defining tech debt as code that you've decided is a liability, right? You can decide whether you want to live with that liability or not. And if you've decided that you don't want to live with it and you don't address it, that's time wasted or problems caused in the code base or just generally speaking, inefficiencies, right?
Yeah, the reason I wanted to bring this up because it's this thing where I feel like I'm glad that one of the reasons I started the podcast is I want to talk about the maintenance aspect of software and not like, you think about other industries, let's say non-software industries. Let's say you work in a maintenance team within a hospital. You have to kind of work around how it was originally built, how things are mapped out, how the electrical stuff, all the stuff that's, you have to kind of work around all that stuff. And I wouldn't necessarily consider that a productivity loss necessary, right? And that's it's upkeep, right? I think there's this interesting thing within the software community where I don't know if it's like as people mature in their career, maybe there's like an arc to being more comfortable with technical debt. Whereas I've met a lot of like junior, mid-level developers who feel like technical debt is this really bad thing and they need to avoid it at all costs. Necessarily, if we do that, we're going to create a bunch of technical debt, and then that's bad. So I'm going to go work at a company that has very little, no technical debt, and so I can spend most of my time building new features. And it's like this panacea of like the ideal environment is where all the software developers only making new things versus say mending existing stuff. And I want to dispel that as best I can in the community, be like, that's the job, is taking care of things, but it's not necessarily how you're taught how to program necessarily. You're building new things, mending, and most people don't get to start their very first job and be like, okay, brand new Ruby on Rails application, here we go, brand new fresh vanilla React app. We have all this stuff that's been built for several years, which made the business be where it's at, where it can even hire people oh, this is a change. I'm not getting to work on new stuff. So I know I kind of went through a lot of different things there, but what's your take on, like, what's been your experience with seeing how people have, come to terms with making versus, say, mending software?
I think that's a very worthy message, what you just shared here. I love the analogy of the professional chef's kitchen to talk about technical debt. You can make food all day, every day, and never wash the pots, never clean the surfaces, never tidy things up. But the next time you're going to come around, you know, I don't know if you've ever seen a professional chef work, but they have their pots and pans in a very specific place. The sink needs to be very close to the fridge because they need to be able to grab things and move around properly. You need to have everything on the same side so people don't end up crossing over. You know, it's things that relate to the same job on the same side. It's really organized. And the first thing you do when you're done cooking is you wash the place, because otherwise some health inspector is going to shut you down after a point. And it's exactly the same thing with software. When you collaborate to build this stuff, you're inevitably going to create a bit of a mess. I don't even want to call it a mess, because it's actually just cook food in a pan. Of course, there's going to be food at the bottom of the pan. You know, you've got to clean it up, right? It is just as much the job to deal with that inevitable mess and the work that comes with it as it is to cook the food. But, you know, chefs are very, very good at cooking food. I can guarantee they're also really, really good at cleaning up the kitchen. You know, like, they are not gonna think of this as some lowly job that should not be done and shouldn't be done properly. And the idea for software is the same. Now, I think, you know, to your point about how software developers are taught to build stuff, well, it's often the case that you start by yourself. So you're not dealing with any other people. You just have your own little project. And of course, you know everything about it, right? I don't know if there's a way around that. Maybe people working on open source projects when they can do it, to learn about how to collaborate here. But to some extent, I think that's part of the thing that we need to teach junior engineers who get started on the job, right? And it relates to the point we were making about how they're trained earlier. If you have good mentors and people who teach you that this is the way it's done, I think you come to terms to it. And, you know, I think that engineers get frustrated with technical debt when they know things could be so much better if they were just able to allocate a few resources to dealing with it. Because there's this misconception with tech debt management, which is that it's going to cost time and it will be net negative, right? It's like, we're going to spend time and I don't know what we'll get out of it, right? It's also it's like the assumption that, kind of like saying that engineering is a cost center. It's like, you're a software company. How is engineering a cost center? Because they're building the product that you're making all of your revenue off of, right? And it's the same with dealing with technical debt. If you do it properly, you end up shipping faster, much, much faster. And it's such a hard case to make with today's tools. You know, I'm excluding Stepsize, that people have sort of thought of this as a fact of life, you know. And if you're lucky, you've got leadership who knows that investing in software maintenance and tech debt results in net positive for the company, you know, shipping faster, people staying for longer and fewer bugs and less support, etc. And if you're unlucky, they don't, and then it's an uphill struggle. So yeah, I think that's why it's a worthy message and something worth explaining to everybody working on software. Not just engineers, everybody working on software.
Hi there. Do you know someone who might be looking for assistance with their Ruby on Rails application? Planet Argon would love to meet them. We're offering a $1,000 referral bonus. Send someone our way, and if they sign up for services with Planet Argon, we'll give them a $1,000 discount. And in return, you'll get a check for $1,000 in the mail, just for knowing the right person. Hop on over to planetargon.com/referrals for more information and to refer someone our way. That's planetargon.com/referrals. Thanks.
I want to kind of pivot the conversation a little bit and talk a little bit, just you as a software developer outside of your own product and such. So is there, if you recall back over the, say last decade of your career, is there something that you felt like you had a really strong opinion about back then that you would completely argue against now? That you've like come full circle around on?
Yeah, so instantly my mind goes to company building as opposed to software building. I've just learned so much trying to build Stepsize out there, if you will. And I haven't shipped any code, to be honest with you, in years. And when I did, I used to write bad code that someone else would refactor at Stepsize. I come from a non-technical background, and I'm self-taught because that was like none of us could write code before we started all these different projects. And that's how we taught ourselves. All of these lessons that I tried to describe in the Stepsize journey about why software is such a complicated and hard discipline, I suppose. I'll give you an example. I used to think that code might be hard to understand because it needed perfect documentation. Well, maybe that's not the case, because if code were written properly, if the right context were shared, if teams collaborated in the right way, people would be aware of the things they need to be aware of, and then they would make the right decisions. So I guess if I had to summarize all these ideas into one big lesson, is that there is so much about building great software that has nothing to do with technical things and everything to do with people and how people work together, right? It's all about how they collaborate. And if you get this right, I think you get most of the other stuff right.
So much about that being in just a company, team, or culture, and code is like an artifact, right? It's not the main thing. And so there's always this kind of like, the more challenge that team is, you just circling back to like earlier point about ownership being like the most important thing. There's people that join companies and they don't necessarily feel like they own it when they first start off, and then some, hopefully, like, where does ownership come from within it when it's already there, and how do people become part of owning something is something I like curious to think about a little bit. But I want to kind of pivot a little bit to also kind of related to that would be let's say there's a few people listening right now who, like, in that experience where like they don't feel like there's ownership right now. It's like, well, it's kind of like everybody's kind of, we're working as a team, we have sprints, but I don't really know who's like no one stepped up and really seems to own how we're approaching documentation or how we're handling these few different aspects to our pull request process or what have you. And it just seems like we don't have the time right now to figure it out. We're just keep working the way we have. What kind of advice could you offer them to start like raising those conversations within their team to hopefully instill, like, get some ownership or to volunteer for some ownership? Do you have any advice that you, based off of your experience?
Yeah, I've thought a lot about this, and not just in that context about, ownership in software development, but ownership in general at the companies you work at. And I've come to the conclusion that ownership is taken, not given. And I'll tell you what I mean by this. Like I said, I have 3 co-founders. We're a very tight team they're all super smart people, very opinionated. It's not an easy place for everyone to end up with ownership, if you will. So the people that we hire at Stepsize are typically people who don't get uncomfortable with the idea of just getting started with a thing. Like, oh, yeah, I guess not everyone agrees, we don't have consensus, but I'm just going to move it forward somehow. And that's what I mean by taking ownership. So if you feel like ownership in your engineering team of all of these things that we discussed isn't clear, just be that one dude or dudette who creates a spreadsheet where you start tracking all of your tech debt and like do it for yourself and then show it to your team. It's the good old idea of creating a prototype or something, a proof of concept, right? And then you'll get them on board on that, and maybe some people will join you. And so, you have your little skunk works like this. If your product people don't really understand what's up with tech debt, gather some resources, try to explain it, use the analogies, use the spreadsheet that you just put together. Even better, sign up for Stepsize, give that a go, do the free trial, show it to your team, and just start doing the thing is the advice that I would give. Like take a small piece of it and start doing the thing, and things will snowball from there.
But Alex, I tried that a year ago, and then I shared it with the team, and no one else joined me. And so if they don't care, why should I care? What's
Yeah, I mean it's the good old issue of I heard this quote recently. I forget how it goes or who to attribute it to, but how large companies have maybe a dozen people who really care about the business, and startups might have 20 of them. It's just the proportions are different here. Look, like if you don't care, why should anyone else? Is what I would say. Like it's if you care, keep going, and maybe why are you complaining is what I would ask. Like why are you complaining? Are you complaining because you don't actually care this much? Are you complaining because you find it uncomfortable to be the only person who's going to do the job that you would like everyone else to do? In my position as co-founder and CEO of Stepsize, I've just come to the realization that if you want people to do anything that you have in mind, the only way to do it is to just do it yourself and hope that they mimic you at some point. And I'll tell you what, I think it takes a minimum of 6 months for that to happen. If there's like a new habit that you want to pick up and for it to rub off on the rest of your team, in my humble experience, I expect 6 months before it happens, And it's really hard because, adopting a new habit for yourself is a tough thing in the first place. So, doing it so consistently that everyone else around you picks it up is that much tougher. So yeah, I'd set the expectations like that.
I like that kind of that take on that. I'm, as a CEO of my own company, not every idea I have is maybe the right idea or a good idea. And I'll be like, hey, let's try this out. And then so for those listening, know that it doesn't matter what level of a role you might have in an organization or how much say you have. It doesn't get easier the higher up you are necessarily to get people to adopt some new approach to something. And so that's, so you have to kind of keep pushing through, and like that's just part of the job is like, let's try this out. And so if anything, I've learned to maybe add in some time boxes like, hey, can we experiment with this, or can we pilot this approach out for the next few months? This isn't a permanent decision, and I think that's something that anyone could take that kind of approach. I think it's a lot easier to get buy-in from people. Like, can we try this out for a smaller period of time and then regroup and see if we want to make some adjustments or toss the idea out if nobody really adopted it by then? I think people can wrap their head around that versus like, ooh, is this a permanent forever thing? It's a whole new thing, right? People are uncomfortable with change at times if they don't really know how it's going to pan out, or is this going to be a lot of work for me to do? So it's maybe one way to kind of help frame that a little bit.
I completely agree. I think that's a great way to go about it. Find the baby step and just get started.
So a couple of quick last questions for you, Alex. So is there a non-software, non-technical book that you find yourself recommending to peers on a regular basis?
Ooh, that's a great question. I'm going to look at my shelf right here and see what comes up. We were just talking about what drives people to instill any kind of change within an organization, or what drives people full stop. And there's this great book by Daniel Pink called Drive. You can't mistake it, that I was recommended by one of our investors, that I find is a great way to understand what motivates people to do anything. It's a simple framework. You'll see there are sort of 4 characteristics that maybe will help you think about how you might want to get the rest of your team on board with whatever project you have in mind, or if you're a manager, how to really tap into people's motivations.
Excellent. Yeah, I'm familiar with that book too. So I'll include a link to that in the show notes for people. There's a couple of books in that area that I've always found quite helpful for me to go back and reference as well. Like, it's not like dangling a carrot in front of someone to get someone to adopt some new approach. That's definitely not the incentivizing. There's all these intrinsic things that you need to account for. All right. Well, so with that, where can listeners best follow your thoughts on software development online?
Yes. So you referred to the Stepsize blog earlier. If you go to stepsize.com, you'll find the big button for the blog there. We have a newsletter where we share all our original content, but also anything that's come up relating to the best ways to maintain software, to manage technical debt, anything about building better software faster. So sign up to that and you'll get all the updates. If you're also interested in engaging with us, you can always come to Twitter and follow us at StepsizeHQ. We can get the at Stepsize one. And I'm on at Alex Omeyer on Twitter. If you want to have a chat about how to manage tech debt, go deeper into any of the topics we discussed, you can also find me on LinkedIn. Like I said, I didn't invent any of this stuff. I just spend a lot of time talking to smarter people than I've tried a bunch more stuff. So I would be glad to hear your story and to share any of the lessons that I've been lucky to pick up from all these other people I spoke to.
Excellent. So we'll include links in the show notes for everybody for that as well. So it's been such a delight having you join us today on Maintainable, Alex. Thanks for talking shop.
Thank you, Robby. I loved it.